Today we're going to look at 10.6, which is law of cosines. And law of cosines is helpful where law of sines fails us. So it's a very handy, solid formula. It always works on any triangle. And then we're also going to find the area of a triangle using a new formula, which leads us to our question: what is a bird's favorite equation? And if you had said Heron's formula, you would have been correct. Because so sorry. In order to keep the time to a half an hour, I will forego doing the derivation of the law of cosines. You do end up using the Pythagorean theorem to derive this law. And the law of cosines is necessary for side, 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 and side, angle, side. It will work on any triangle, like I was saying. However, law of sines is easier, so it's nice to use law of sines, but you could use law of cosines if you wanted to. So let's write down the law of cosines. There's three ways you can write it. You could do little c squared equals a squared plus b squared minus 2ab cosine of big C. So I'll go ahead and do all the versions. Or you could have had little a squared is b squared plus c squared minus 2bc cosine of big A. And if you're noticing a pattern, you would know the last one is going to be b squared would be a squared plus c squared minus 2ac cosine of big B. Notice that the angle and its side opposite, the side opposite it is out here by itself on the left-hand side. And then, so notice these two are pairs. And then these are all sides here. So there's only one angle involved in this formula, whereas with law of sines, two angles were involved in the formula. And then you can see it starts off a lot like the Pythagorean theorem, but then we're going to subtract 2 times these two legs. Okay. It's actually a fairly easy formula to remember somehow. It just is nice. Our brains like it. And you will need to memorize it. If you use it enough, it shouldn't be too hard. And here it is again. Okay, we'll start with this example. And I always recommend drawing. So I've got an angle C that's an acute angle. 32.2. I like to put my acute angles over here for some reason. And it doesn't really matter where you put, I'll just put A here. If that's 8, then the other side 5 has to be smaller, so it's sort of helpful to draw it somewhat to scale. That way you can kind of check your answers at the end and just make sure they're remotely correct or that they remotely make sense. So here's a possible triangle. And we are going to find all the missing parts. So if this is little a, then this would be big A, little b here. Oh, I didn't draw that right. What am I thinking? Oh my goodness, that's embarrassing. That is not even close to being drawn correctly. Okay, well, we can fix that. What I need to do is, I'm a little embarrassed I made such a silly mistake. Okay, the side opposite is little c, and then the way I've got this drawn, my big side, I want it to be down here, and then little b could be here. Okay, that's much better. Big B is going to go opposite little b. Large angle A is going to go opposite little a, and now I have a much better triangle. Notice we are given information side, angle, side, so this is clearly going to be a law of cosines problem. And obviously the angle we're dealing with is angle C, so I'm going to be using the form c squared equals a squared plus b squared minus 2ab cosine of big angle C. I don't know c squared. I do know little a is 8, so 8 squared plus b squared is 5 minus 2 times parenthesis 8 times 5 times the cosine of angle C, which is 32.2 degrees. And for some reason I'm out of breath. Don't even know why. So now this is all. Notice our variables on the left here, and all of this it can be done on the calculator. And then once you do all of this, you're going to want to take the square root of it. I can go ahead and show that here. So we'll go to the calculator. Now I have been using my calculator in other classes today, so I have to check my mode. So I believe I was in radian. Oh, I'm back in degrees. I was using radians earlier today. So we're back to degrees, which is good. All right. I'm going to do all this stuff underneath and get an answer and then take the square root. To me, I find that just easier to type in. 8 squared is 64 plus 25 minus, I like to do some of this stuff in my head. 8 times 5 is 40, and 40 times 2 is 80. And then the cosine of 32.2. I highly recommend typing that all in. If you don't want to write 80 there, you can do 2 times 8 times 5. That's perfectly fine. Either way, you type it in. You should, when you hit enter, you should get 21.3. Now I'm going to do second square root, second answer. 4.6. I like to round, well, it says round to the nearest tenth. I like hundredths myself. 4.6. We don't have units. I'm going to kind of look at this thing and make sure it makes sense. It does, because I drew my triangle after the second try, somewhat to scale, so that I can make sure my answer seems reasonable. All right, now we could use law of cosines if we wanted to find either angle A or angle B. I was looking at this to see if, yeah. And you know what? That's a fail-safe way of doing it. You'll get the right answer as long as you type it all in correctly. However, law of sines is easier to use. But law of sines is a little bit tricky. I don't know if we talked about this, but when you do inverse sine of some number, A, I guess. Inverse sine, remember, it's defined in quadrants 1 and 4. So if you're doing inverse sine and it's a positive answer, it's only going to give you an answer in quadrant 1. Because we're not going to be doing inverse sine of a negative number on these, because these are real life triangles and they're always positive. What I'm trying to say is that in quadrant 1 is between 0 and 90 degrees. If we're trying to get an obtuse angle, trying to find an obtuse angle, and we're using inverse sine, like law of sines, we're not going to get our calculator to give us an obtuse angle. It will only give us an acute angle. So we're only, in quadrant 1, that means we're only going to get an acute angle. What that means for this problem is I don't want to use law of sines to find angle A, because the way that if I've got my picture drawn, you can see it's possible that angle A is obtuse. And if it is obtuse, law of sines will not give us an obtuse angle. It kind of misleads us. So I need to use law of sines to find angle B. And I know that's a little tricky, but that's just the way it is. So if I want to find angle B, I'm going to have, I like my variable on top, sine of B over little b equals, and then you can use, 4.6 we have to use. So we have to do sine of 32.2 over 4.6. And then to solve, we're going to multiply both sides by 5. And then we'll do this on the calculator. So that's going to be 5 sine 32.2, enter, divided by 4.6, enter. And then we have to do arc sine of that. So second sine, second answer to get our angle. And we get 35.4. So measure of angle B is 35.4 degrees. We'll box that in because that's one of the things we wanted to find. And now it's easy to find angle A because you can just add those up and subtract from 180. So, this little bit, okay. 180 minus parenthesis 32.2 plus 35.4, enter. Sure enough, it is obtuse, 112.4. Just real quickly, what I'm going to do, I'm going to erase down here. I'm going to show you what would have happened if I had tried to find angle A first instead of angle B using law of sines. So this is what would happen. So say I was trying to find angle A, I would have sine of A, because I don't know what it is. We're pretending I don't know it yet. And then I did know C, so I knew sine, I'd have sine of 32.2 over 4.6. Then I multiply both sides by 8. Go to my calculator. 8 sine 32.2, enter, divided by 4.6, enter. And then I have to do inverse sine of that. So this is a positive number here. When I do inverse sine, I'm going to get a number of an angle in the first quadrant, since this is positive. Second sine, second answer. Oops, I don't want that plus there. That's not going to work. See, it's 67.9. Well, angle A is obviously not 67.9. So if you had chosen to do angle A first, you would have been in trouble. You would have gotten the wrong answer. So you just have to be smart about it when you're doing these things. Please write this down right here. This is really important. Okay, we have solved this triangle. We are done and ready to move on. Okay, now this is side, side, side. So again, I'm going to draw a triangle. Hopefully I'll have better luck this time. We'll put the long side down here, 8, 7. This is C, 9 is B, this is A. Okay, again, we have to proceed with caution, because what we're going to do on this is we're first of all going to find one of the angles, and we have to use law of cosines because we don't have enough information to use law of sines. But then after we do that, we're going to use law of sines to find the other angles. Remember, law of sines will not give us an obtuse angle. So that means we want to use law of cosines to get the obtuse angle, because we know we're not going to be able to get it with law of sines. So first thing is use law of cosines to find the largest angle in case it's obtuse, because law of sines will not do it for us. So the largest angle, according to my picture, because I've drawn it somewhat to scale, is going to be angle B. The angle opposite the longest side. Okay, so angle B is going to be over here. It's going to be cosine of B. Remember, my law of cosines is really big. And so I know that my little b is going to be over here by itself, so 9 squared. And then here I'm going to have little a squared plus little c squared minus 2 times a times c. I plugged the numbers in. Maybe I should I could show you the. So this is b squared equals a squared plus c squared minus 2ac cosine b. That's the version that I used. Now I chose that version because I'm trying to find the largest angle, which is angle B. Now, to solve this, it's helpful to do a little bit of algebra before we put it in our calculator. A lot of these I can do in my head too. So, but I won't. Well, I will maybe. 9 squared is 81. And then I'm going to need to subtract the 60, this is 64 and this is 49. I need to subtract those, so minus 8 squared minus 7 squared. Of course, I just want to do this on my head, but I probably shouldn't. 8 times 7 is 56. I like to simplify it as I go just to make it easier. So what I did there on that first step is I simply subtracted the 8 squared and the 7 squared and got it over on the other side, because my goal is to solve for b. Now I can divide both sides by negative 2 times 56. That cancels out. And then I'm going to do this on my calculator. It's really important to do the entire numerator first, and then the tricky thing that gets people is this bottom has to be in parentheses. It'll get you if you're not watching. So I'm going to have 81 minus 8 squared, which is 64, minus 7 squared, which is 49. Hit enter, divided by parenthesis negative 2 times 56. If you don't put it in parentheses, you're going to get the wrong answer, because you're dividing by that entire denominator. Okay, so that is equal to cosine of b. That means we have to do inverse cosine in order to get b. So second cosine, second answer, enter. And angle B is 73.4 degrees. Oh, it wasn't obtuse after all. All right. All right. I wasn't quite expecting that, was I? But it is what it is. So now we can use law of sines to find either of the other angles, because we know we found the longest one. So these both have to be acute. So I'm just going to pick C. So we're going to have sine of angle C over little c, which is 7, equals sine of angle B, which is 73.4, over little b, which is 9. Multiply both sides by 7. Do that in the calculator, take inverse sine. I'm just going to look at my notes to save time. When you do all that, because I think you guys are good at that by now, you should be getting 48 point, I have 19 here. It says round to nearest tenth, oh well. Then you can add those two together and subtract them from 180 and get the measure of angle A, which in my notes I have as being 58.41. Okay, that one is done. This is an on your own, so you can pause and do this on your own, and then I'm going to just simply supply the answers. This looks like this is going to be a side angle side problem, similar to the first example we did. So you're going to be using law of cosines to find little a first, and when you do that you should get little a is 40.92, and my notes here I've got it rounded to the nearest hundredth. And then you can use law of sines to find, you already know the largest angle is 173, so you can just use law of sines to find whichever angle you want. You'll get measure of angle B is 3.93 degrees. The measure of angle C is 3.07 degrees. Right, because 173 is so close to 180, you don't have much room for these other two angles, so it's a pretty squatted little triangle. And then this is an example so you can get practice with side, side, side. So again, I'm just going to give the answers to save time. So looking in my notes here, now on this one, you do want to find the largest angle first, which is going to be the angle opposite the longest side, so it's going to be measure of angle C. And in my notes I have 81.02, so that's not obtuse, is it? Measure of angle A is 43.4 degrees, and the measure of angle B is 55.6 degrees. So you'll work that in a similar fashion to how we did the example with side, side, side. Moving along. If a hiker travels at an average speed of 2.5 miles an hour, which is pretty darn fast, they must not have much of a pack on, how long will it take him to travel from the cave to the waterfall? So they're trying to find this length here. I'm going to call it, I was going to call it little c, because this is cabin, big C here. Oh, sorry, round to the nearest tenth of an hour. Well, they're giving us the hiker's speed, but then on this triangle they're giving us distances. If we know a distance and we know a speed, can we find the time? Because it wants hours, it wants time. Yeah, we can use dirt, right? So that means we need to know this distance in order to use dirt. So we need to find C. This is side angle side. We can use law of cosines. So we need to find little c. That's going to be c squared equals 3 squared plus 4 squared minus 2 times 3 times 4 times cosine of angle C. See how easy that is? Type that all in the calculator and take the square root. I am going to check it on my notes to save time. It looks like I got 4.18 miles. All right. And then we can plug that in the dirt formula in order to get the time. So I'll just plug it in there. Let's just do 4.18 equals rate 2.5 miles per hour times the time. That means we're going to be dividing both sides by 2.5. And when we do that, we should get 1.67 hours for our final time. Here's an on your own. I could talk about it a little bit. A pilot is flying from Houston to Oklahoma City. To avoid a thunderstorm, the pilot flies 28 degrees off the direct route. So the pilot's wanting to go this way. This is the goal. But instead, he or she, oh, it's a he, heads off to the east a bit, or northeast, and then is going to turn. So he goes 175 miles, and then he makes that turn. And it says to the nearest mile how much further than the direct route was the route taken by the pilot. So we need to know this entire distance, right? So we can compare it to this 396, which means we already know one leg of it. We need to find the other leg. I'll call it little L for leg. We've got side angle side again, don't we? Side angle side. So you can set it up with the law of cosines. So you're going to have L squared equals 396 squared plus 175 squared minus 2 times 396 times 175 cosine of 28 degrees. And you can plug all that in the calculator at once, get an answer, and then take the square root. And then you get L equals 255 miles. Okay, so that's this leg. And I'm sure you can see that you're going to need to add those up and then subtract that 396 from that sum to see the difference. So 255 plus 175, get a sum, and then subtract 396 to see what the difference is between those two. And I have 34 miles here in my notebook. Alrighty. Now it's time to look at yet another area formula. So our third area formula for triangles. The first one is the one we learned from geometry, 1/2 base times height. The second one was the one involving sine, like 1/2 AB sine of C. Now we have something called Heron's formula, which is when we have side, 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 when we know three sides of a non-right triangle. As handy as this is, we hardly ever really use it. Plus, it's kind of hard to remember. I mean, it's easy if you're working with it, but it's hard to remember. Like from a few months from now, are you going to remember this formula? Probably not. Anyway, in order to do the formula, you have to do a preliminary calculation, and you have to find S, which is this little formula here. So you simply add up all the sides, get a sum, and then divide by 2. That's your S. Then you take that S, and it goes underneath the square root, and then you can see here the formula. So let's use this on the next example. We have a garden with a triangular flower bed, and we have those three sides, 2, 6, and 7. What is the area of the flower bed? Okay, so using Heron's formula, we're going to find S, which is 1/2 of the sum of those. So 8 plus 7 is 15. 1/2 of 15 is 7.5, so that's our S. And then the area is the square root of S times S. Whoops, let's go back. Here I am. Why don't I write the formula down? Why not? That's what I seem to want to be doing. S minus A times S minus B times S minus C. Okay, now I'll plug numbers in. So S square root, big square root. S is 7.5. 7.5 minus A, which is 2, times 7.5 minus 6, times 7.5 minus 7. And you can type all that in your calculator at once if you want, or you can simplify it a little bit, then multiply and take the square root. Give it a try. And looking at my notes here, it looks like I got 5.6 yards squared. Yeah, I was looking at its square yards, all right. Sorry, I'm yawning. End of the day. And this is your last one to try on your own. They have a swimming pool. They give you it's triangular. They give you 3 of the sides. What's the area? So you're going to do the same old thing, find S, and do the whole Heron's formula. I'll write it out, I guess, for you. 1/2. It's going to be 50 plus 28 plus 30. Your S is going to be 54. Plugging all that in the area formula. 54 times 54 minus 50. And some of this, you know, you can do in your head, or you can do it all out. 54 minus 30. Crunch all the numbers, and the answer I have here is 367 meters squared. And that concludes the lesson. So the area formula, the Heron's formula, is not that bad. When you're using law of cosines, just remember on side, side, side to use law of cosines to get the largest angle first. And then if you're using law of sines, remember that law of sines will never give you an obtuse angle. So if there's a chance that the angle you're trying to find is obtuse, don't use law of sines to find it. Find an acute angle instead. And those are my words of wisdom for today. And with that, I'm going to sign off.